Welcome to The Explainer. Today we're going to talk about something that's everywhere, data. We're going to peel back the curtain and see how a bunch of raw numbers actually becomes a powerful, game-changing insight. Let's jump right in.
Think about it. We are just swimming in data every single day, right? Business reports, your social media, it's just a constant stream of information. So the real question is, how do you take all that noise and turn it into something that actually means something? This isn't just for tech gurus anymore. It's a skill we all kind of need to understand.
So to really get a handle on it, we're going to go on what I'm calling a data journey. We're going to follow a single piece of data from the very beginning, like when it's just a number in a database, all the way to the end where it becomes this compelling story that anyone can look at and understand.
All right, so every journey has a starting point, and for us, that's the database. But here's the thing, you can't just, stroll up to a database and ask it for what you want. Nope, you've got to speak its language.
And the most important language, the one that's basically the foundation for everything, is SQL. That stands for Structured Query Language. And get this, it's been the go-to way to talk to databases for decades. It was invented way back in 1974, and believe it or not, it's just as crucial today as it ever was.
When you look at it, SQL is really just a super specific way of asking a question. This code here might look a little technical, but all it's really saying is, hey database, can you please show me the first names and last names from that table called person? Oh, and one more thing, I only want to see the people whose last name is Adams. See, it's just a very precise request.
I love this quote. It's the perfect way to think about it. If your final analysis is like cooking an amazing meal, then using SQL is like giving the kitchen a super detailed shopping list. You're not asking for the entire grocery store, just the exact ingredients you need for your recipe. Nothing more, nothing less.
Okay, so we've used SQL to get our raw ingredients from the database. Now the real fun begins. This is where we actually start cooking. And for the heavy lifting, like finding hidden patterns and building complex models, we need even more powerful languages.
And in the data world, there are really two heavyweights, Python and R. Think of Python as your versatile, all-purpose tool. It's famous for being easy to read, and you can use it for pretty much anything. Cleaning data, machine learning, you name it. R, on the other hand, is the specialist. It was built from day one specifically for hardcore statistical analysis, which is why you see it so much in academic research.
And what's really wild is when you look at this timeline. SQL laid the groundwork back in the 70s. Then Python and R came along in the early 90s. These aren't some new, flashy trends. These are the time-tested, rock-solid pillars of the entire data industry. And they've been around for over 30 years.
Okay, so we've got the languages down, but where does the actual work happen? Where are people typing out all this code? And maybe more importantly, how do teams work together on huge projects without messing up each other's work?
Well, they're definitely not just using a basic text editor. They use what's called an integrated development environment, or an IDE for short. The best way to think of it is like a coder's digital workbench. It's got everything you need, tools to write the code, tools to test it, tools to fix it when it breaks, all bundled into one single application. You've probably heard of some like VS Code or RStudio. And because data analysis is almost always a team effort, they use tools like GitHub to keep everything straight. It's a pretty simple cycle, really. You write some code, you commit it, which is like saving a snapshot of your work, and then you push it up for the rest of the team to see. GitHub basically keeps a perfect history of every single change ever made, so nobody's work ever gets lost and everyone's on the same page. It's a lifesaver.
All right, so we've asked for the data, we've analyzed it, but now what? What happens when you need to send that data somewhere else, like from a server in a data center to the browser on your phone? How does that information travel between two totally different systems?
It needs to be packaged up for the journey. And to do that, we use standard formats like XML and JSON. You can think of them as universal shipping containers for data. They wrap everything up in a nice, neat package that any computer system, anywhere, knows how to open and read.
And if you look at the two, you can kind of see why JSON has become so popular. It's just cleaner. It's less wordy, which makes it lighter and faster for computers to handle. And in the world of the modern web, that efficiency is absolutely everything. It's why it's the standard for pretty much all modern web apps.
Which brings us to the final step. And honestly, you could argue this is the most important part of the entire journey. It's where we take all that complex technical analysis and turn it into a visual story, a story that anyone can understand at a glance.
So,
After all our work, we might end up with something that looks like this: a plain old table of numbers. I mean, sure, the information is all there, but it's not exactly telling you a story, is it? The main point is hidden in there somewhere, but good luck finding it quickly.
But this is where the magic really happens. Using what are called business intelligence tools, or BI tools for short, things like Tableau or Power BI, we can take this boring table of raw data
and turn it into this: a simple, clean bar chart. Boom! Instantly you see the story. We have way more dessert plates in stock than anything else. That is the whole point of this journey. Taking something complicated and making it so simple that anyone can understand it in seconds. That's the real payoff.
So that was our data journey from start to finish. Now let's just take a step back and look at all the pieces we just put together. Let's recap the whole modern data toolkit that makes this amazing transformation happen.
When you boil it all down, the whole thing is really a simple three-step process. First, you ask a specific question with SQL to get the raw data. Then, you analyze that data with Python or R to find the hidden story. And finally, you visualize your findings with something like Tableau to share that story with the world. Ask, analyze, visualize. It's that simple.
And here it is, the whole shebang, the complete toolkit. You've got your languages for asking and analyzing, your workbenches for writing the code, your collaboration tools so teams can work together, your data formats so it can travel, and finally, your visualization tools to make it all beautiful and clear. They all work together.
But, this toolkit is never static. It's always changing. And right now, the big change is AI. We have AI assistants that are getting really good at helping write the code for every single step we just talked about, which leaves us with a pretty big question to chew on. What's the next stop on this data journey going to look like?